Discuss the next question, number 27. Two coins R and S are tossed. The four joint events HRHS, TRTS, HRTS, and TRHS have probabilities 0.28, 0.18, 0.3, and 0.24 respectively, where H represents head and T represents tail. Which one of the following is true? So we have our four options. A says the coin tosses are independent. B says R is fair while S is not. C says S is fair, R is not. And D, the coin tosses are dependent. Okay, so there is a certain equation that we can try and analyze in order to see if it's independent or not. So that would be our first step. Let's check if the coin tosses are independent or they're dependent. And then we will go into whether they're fair or not. Okay, so one way in order to find out if the coin tosses are independent is by the equation, the probability of the joint event HRHS is equal to the product of the individual probability, which means the probability of HRHS should be equal to the product of probability of HR and probability of HS. If this equation satisfies, then that tells us that the coins are independent. The coin tosses. Right. Okay, so if this equation is not satisfied, then it would mean if they are not satisfied, then the coin tosses are dependent. So let's first check this. We'll note down the given probabilities and then begin. Okay, so we have the joint probabilities given to us. P HRHS equals 0.28. Probability of TRTS is 0.18. Probability of HRTS is 0.3. And the probability of TRHS is 0.24. Okay, so now we will have to use the formula from total probability theorem. Now please recall, if you are familiar with this, that's good. By total probability theorem. Now the equation is the probability of HRHS plus the probability of HRTS equals the individual probability of HR, the coin R of heads. Now we have the values of both of these probabilities, and then we can find out what the probability of HR is. Let's substitute the values. Now what is the probability of HRHS? That's 0.28. 0.28 plus this is 0.3 equals to P of HR. So P of HR, adding up the two values, 0.58. So this is our first value. Similarly, let's find out what is the probability of PHS. Okay, so that's our next part. Using the same concept, we can write the equation PHRHS plus probability of TRHS. This will give us probability of HS. So we have TRHS here as 0.24. So let's substitute 0.28 plus 0.24 equals probability of HS. So here, Adding up the values, what do we get? We get 0.52. Now we have probability of HR as 0.58 and we have the probability of HS as 0.52. So now let us substitute both these values along with the values of these two probabilities here into the previous check question that equation that I wrote down in the very beginning. So the equation was probability of HRHS equals the probability of HR probability of HS. So now let's substitute. What is the probability of HRHS? That's 0.28 equals probability of HR is 0.58, probability of HS is 0.52. Now we see here that they are not equal to each other, which means that the coin tosses are dependent. So this straight away gives us our answer, our option. The coin tosses are dependent. Option D is the right answer. So it basically comes down to the check equation whether they are dependent or not. So this is the entire solution and I hope it has helped.